Standard error, yeah.
You give an example in your notes that the order of the magnitude.
Okay.
The example is here, prog, log.
Oh, yeah. Okay.
It seems that the result must be the same, but based on your notes, it must be different.
Okay, right. So this is a slightly more advanced thing, but I will answer it. Okay. It's not something that I'm going to test on this test. Okay. I might ultimately test it in a final exam, but if I were to do so, I'd cover it more. So the question here is that there's on the slide there were two commands given, and I'm going to show this, even though I didn't spend much time in class. So one is some program name, and we have greater than log, and then we have 2 into 1 here, okay. And then another one, we have prog here, 2 into 1, okay, and then we have log here. Okay, so help me. So there's some pieces here that everyone should be able to recognize, and there's some pieces that are unfamiliar. Still good back. Thanks. So what's this prog? It's a command. Something that we started, right? Okay. What's this thing with greater than log? Yeah, it's outputting the standard output. Okay. Now, the thing that may or may not be familiar, because I went through it really quickly, but and therefore I'm not testing it tomorrow, is this issue here. What does this mean? Sorry? Okay, right. So what is this 2? Standard error. Okay, so it turns out that we can number the different outputs here, 0, 1, 2. Okay, so 0 input here, 2 is output, standard error rather, and standard output. And so what this is saying is that, okay, put your standard output into log, and then by the way, for further, then add in the standard error into this, okay, into the standard output. Here we're saying, okay, treat the standard error as going to standard output, and then put the consequence to the log, okay. So these two actually do give different things because of the ordering here is reversed. And so, memory serves me, this first one, where it dumps to log, it's actually not going to get the standard error as part of log. Here it is, because the standard error, you've been told that, hey, add that into the log stream, into the standard errors. Excuse me. Add in the standard error into the standard out stream before putting the standard out into log. Okay? Here we put the standard out into log before we told it to add standard error to that standard out, and therefore what goes in log is not going to incorporate the standard error. Okay, so that ordering, it does pay attention to it that much.
So
does that make sense?
Yeah, the first one is supposed to be prog, and the second one is supposed to be prog. Standard output and standard error.
Standard output here, if memory serves me, standard output will not be part of log here. It will be part of log here because it gets added to the standard output here prior to that.
And the first one will be part of what? Part of prog.
I mean, where will the standard output, standard error go? You mean for this one?
Yes. Going to the standard output.
It's not going to go into the log file. In fact, it's not going.
My understanding
Yeah.
of the first one is that both the standard error and the standard output going to the standard output.
That's correct. That's correct. But it does so after it's put into log. So it's not being going to be reflected in log. In both cases, it's saying somewhere put in standard error into the standard output. It's not doing it in time here to get it into the log file because it appears after that. Here it's doing it in time. It's saying, hey, before putting it to log, make sure standard error is part of standard output, and then put put the standard output into log. Does that make sense?
So if we do cat log, we can have the second one.
If
The second one,
yeah.
if we have cat log, we should suppose that both standard
Right.
both of them.
Right.
But for the first one, if we do cat prod,
cat log.
once again cat log.
Cat log. Yeah, the prod here is just the name of the program.
Oh,
It's just the name of the program. Yeah. It's not an actual file that's going to be changed by things. Log is going to be changed by things. Okay. So one of the reasons I didn't emphasize this is it's a little bit confusing for people to see this ampersand, because this is greater than ampersand all right next to each other. And ampersand is used for something else. What is it used for? It's used to tell something to be a background process. I didn't want to get really confused about this. But I'd be glad to talk more about this later, and we can try it out. Okay, folks, so if we have this sort of thing, what do we print out? Does it print out $n bar? No, it prints out the contents of the variable, okay? Depending on shell, you can use n for printf to see all the environment variables. So certain shells, including sh and bash, if you want to set the environment variable, something that's seen by multiple programs, by multiple shells that are running, you want to see a certain environment variable to have value across all of those different systems, you would do it like this. If you just wanted one that's used by your particular shell for this particular shell session, you can just say, you know, depending on the shell, you could say set, you know, my var equals, you know, 1, or you could, in some shells, you could say my var equals 1. Okay. So export is used if you want to sort of let other things see it. Okay. So greater than. What is that used for? Sorry, appended. So here, the output from date is appended to the end of log. Okay. So whenever date outputs, it goes at the last part of log. In this case, it's the last line of log. The file log contains the output from date. Does that make sense to people? Okay. Okay, we talked about file permissions. And ladies and gentlemen, there's basically 3 types of permissions you can grant: read, write, and execute, or search or open as a directory. And then 3 types of levels of granularity, 3 types of levels of specificity, of exactness in who you're specifying. So, are you specifying a permission for a specific user? Are you specifying it for a group, or are you specifying it for other individuals? Okay. Now, user here is the. Sorry. Yeah, it's the owner of the file here. Is typically how this is going to be set up. Group is going to be, there's going to be some group associated with the file. It's a group of sysadmins, or it's a group of developers, or it's a group of professors that are associated with this file. There's one group associated with it, and you can change that for sure group, although I'm not going to be testing that. But if you can specify it for the group, you can specify group permission that says, like, what can other faculty see about that? And then there's a global permission, as indicated by O, which indicates for other people, other types of individuals. In a classic example, would be people coming through the web, for example, or the public if they can see your system in some sort of way, or all other people. So, you know, in my folder, I'm in the group faculty, so I can give myself certain permissions as the owner of the file. I can give the group of other faculty, they can see certain things. Maybe they can see my exam question. You know, all others, such as yourself, can't see the exam question, like it or not. You can't see those exam questions until, of course, tomorrow in this very room. So So here we can specify for these different groups what they can access. So for example, maybe I'm the only one allowed to change, modify the file of my exam questions. Maybe all faculty they can read it, but they can't write it. And maybe you folks can neither read it or nor write it. Does that make sense? Okay. Execute and search. What's that used for? Okay, it's a type of permission. And under what situation would someone want to execute something? If it's a program, that's a good question. What's another case where you want the execute bit set? Even though it doesn't seem like execute, but it's an extremely important case. Sorry? Okay, but to actually go into directories. Okay, so if you have a directory, and you want to be able to go into this directory as the owner, it needs to have the execute bit set for you to go into that directory. Kind of intuitively, you can think of it as when you see that directory, you're executing the directory in some weird sense. So it's associated, if you want someone, say someone from the web needs to be able to go into a directory so that they can get a file from there. So maybe you've got, a folder, www, dot, this is in DOS land, and I hope I didn't pollute you with any other ideas. Okay, so /www/store or something like that, or /images, maybe that would be a better one. If you had an image here, maybe it's a, foo.jpg, and you had an image here. If you want to give permissions so that users coming in over the web can access it, so they can type in their URL, my site /image/foo.jpg, and get that. This folder, www, this folder, image, have to be associated with execute permission. They have to be associated with permissions so that you can kind of go into them to grab this file. If they're not, it's not going to actually be able to get what's in there. It's not going to be able to see, inside of www there's an image thing. It doesn't allow that. So this X permission is used to be able to access it, to kind of go into a folder. If someone is allowed to access that folder, then you have to be able to use the X attribute there. Okay, so that execute search attribute. Otherwise, it can be used to set something up called myProd that you can execute. Okay, does that make sense to people? This is, by the way, this is like bread and butter issues if you're setting up a web system on a Unix box. This is, this is something like almost as basic as, putting a fork in your mouth or something like that. It's like setting the execute permission for folders. This is like one of the biggest problems that occurs with websites. I don't know how many times I've run into this. I can't access the folder. Oh, it's just because I didn't set the XBit on for public. I have to go, time to go set the XBit. How many emails I've gotten saying, I can't access this file. Students or whatever, and I go and I set the XBit. It's a pain, but it's day-to-day reality. So setting the XBit is required for folders if you want to get what's in the folder. You want to grab it. Now, I don't want to confuse you too much, but that's different than an RBit per folder, which allows you to actually see what the contents are. This allows you to grab what's in there, but you can't actually see everything that's in there. That would be the RBit. If you have that set, then you can see, there's foo.jpg and var.jpg and my exam.jpg. If I don't want you to see that, I just say, you have the XBit, and if you don't have the RBit, the R set for read, then you can't actually see everything that's in there. You can't get a listing of what's in there. X allows you to grab the image inside that, grab this foo inside this image folder. Okay? Okay. So X is used for directories and it's used for execution of a program. Okay, any other questions on this particular sort of high-level thing there? We, of course, encode, oh, I thought I actually had that. Oh, gosh. So how do we encode this, folks? How do we encode this? How do we change these things? So I have a file. So someone tells you, hey, I can't see my file. Or I can't see the contents of the file. You want them to see the contents of your file, and they can't see it. What do you do? What program do you use to change it? Chmod, yeah. Chmod. And how do we, there's two ways we can specify things to Chmod. Suppose they wanted to allow, for example, a user to be able to access, so the owner to be able to write to the file. What would I do? What could I say? Sorry? U plus R. So I'm setting for the user, in other words, the owner, they're allowed to read it. How do I want to set them to be able to write it? U plus W. How do I want to say they can't write it? Minus, yeah, minus something here. Okay, good. Now there's, and then the name of the file. Right? Okay, so that's good. Is there another way to do it besides these things? Yeah, well, it's an old school way. How would you specify it? You have octal digits, so you can set, for example, 664, for example, or 777, and each of these digits, it goes between 0 and 7, and each of the bits in that is 3 bits. 3 bits, and it goes numbers from 0 to 7. And each of those bits stands for something. It stands for, whether you can read it, whether you can write it, and whether you can execute it. I'm not going to require you to memorize that whole stuff, but you should realize that that's pretty common. In fact, in certain things, when you go in, certain FTP, have you folks seen FTP? How many people have covered FTP? Okay, FTP is a program to transfer files from one machine to another. And if you're in the business of building a website, you're going to be using FTP up to the wazillion. And you're going to be using it to transfer files between your system and that system, etc. And FTP, certain FTPs will just list like this things in this format. You got to be able to interpret them. So one of these is for the user, another is the owner, one is for the root, and one is for the public, and then each of them encodes whether it's read, write, and execute. Okay, so you should just know about that. Okay, so we mentioned the file system fundamentals, stood in, stood out, and stood error. That's good. And by the way, folks, in case it hasn't sunk in, these are the strings that you have access to in C as standard input, standard output, and standard error by the stdio library. So if you do pound include stdio, right? Or stdio .h here. If this is the library you include, because you want access to, scanf or something like that, or fscanf to look in a given file stream or what have you. You're going to be including this, and it defines standard output, standard in, and standard error, and those are just the standard in, standard input, standard output, and standard error that are provided by Unix. Okay, so and those map to, I don't know how I should pronounce this, sin, sout, or kin, kaut, and care. It's awkward either way, as defined in C++. Okay. We kind of talked about this. This is kind of more advanced, and I don't expect you to know it. So, so folks, what's a process? What's a process? A process is one of those concepts that I ask you to learn about in engineering. What's a process?
Has computers working on it.
Fair enough. So it's sort of an independent thread of control, an independent sort of activity that it's working through. It's associated with some of its own memory, and it's associated with some arguments, potentially some information given to it, and it's running independently, concurrently with other things. So it's running at the same time as other things, okay? And it has access to a bunch of resources, not only memory, but things like that is open and network connections and all those sort of things. Okay, so it's in some address space. In other words, it has access to its own sort of little set of memory that other things can't frog. They can't change it willy-nilly. Okay? Right. So when we do something like foo, pipe, bar, how many processes are created there? Two. They're running in parallel. On Unix, they run in parallel. So foo is running at the same time as bar. So this is starting with foo. How do I put? I'm trying to help you understand this. How do I put a semicolon? How many have started at the same time? One. Foo executes and then bar executes. There's other ways to drawing these up too. Ampersand, ampersand, for example, will run this and if it returns true, it will run that, etc. But the fact is that if we're running it with the pipe, they're running at the same time, okay? And so we have these things running concurrently. A single command has started more than one process there, okay? And processes exist in a hierarchy. And we saw this in class when I presented it. You could see it in the video from that day. So if I execute this, maybe I'm in bash. Maybe I log in and I go to bash and I go into the bash shell. And then maybe I execute this command. Now foo will be a child process of what? Of bash. And bash may be a child process of some logging process or something like that. So it got started by bash. So if I kill bash, if someone went and they said kill -9 my bash, the system administrator, they said his bash is chewing up too much memory or it's chewing up too much CPU time. Let's kill it. They kill it, it would kill this as well. This one is sort of a child of it. It's dependent on it. So this does stuff. It goes away. Okay? It's a child process. So they could kill this and any children. It's very common. So there's an option when we go look at processes to ask, we want to see themselves and see how they relate to their parents. Okay? We saw that in class. And each process has a unique identifier with it. So foo might have a process of 1001, and this might have a process of 2 or something like that. And they can each be identified, and we can use that to kill them, for example. Let's say kill number 1001, and it will disappear. Okay. So here are these processes. So we might have a grandparent process, a parent process, a child process, etc. Okay, and in many operating systems, this is true for Windows, this is true for Mac, it's true for Linux, it's true for Android. You basically have processes running, and they have some statistics which are kept on the amount of memory that they have, how often they're, how much swap space they're using, how much CPU time they're using, and all that sort of stuff. And then on some of these systems, you keep track of who started them or who's responsible for them. You notice the process ID here. Okay. So we can list these things out. PS tree is the one I demoed in class. Okay. So PS is also very commonly used to list the processes. Okay. And it has various options to list processes by other people, not just by yourself, etc. Who can tell you sort of who else is logged into the system right now, who else is running things in there, and exit can leave the system. We saw Control D when we had to end, for example, standard input. Where do I use Control D? Can anyone tell me? Yeah, standard input. So if I say, cat, and I want to pipe it to sort, for example, if I do this, it will just be saying, okay, tell me what to give. It's waiting for its standard input. So I can type line after line. When I'm done, I would type Control D, and then that file will be finished. Meanwhile, every single line it's giving it to sort. Telling sort, hey, here's another one, here's another one, here's another one, and when it's all done, boom, sort can do its job and be done. But it's actually sort's getting them one-on-one. Okay? Okay, so we talked about a notion of a foreground process and a background process. Background process is one that executes. It doesn't require user interaction. It's not in their face. It's not waiting for their input. A foreground process is one that's associated with user input. It's control the people. When you type something, it goes to that process. Okay? Thirdly, if you're using an Android device, there's certain things that run in the background that you're not looking at right now, and there's certain things that run in the foreground. Here, this would be, for example, a foreground process because I'm typing things into that. Okay? So how do I make something? So if I have a really long-running thing, I want to do, sort of some, terabyte database, TB. And this is going to take hours. What can I do to make it run in the background so I can do things while this is running? By the way, I probably won't put it this way. I wanted to print out standard output. It's terabytes long. So I could put it out to, to some TB terabyte sorted database or something like that. Good enough. Okay, so what can I do to put in the background? When I type this, what do I type to put it in the background? Ampersand. I don't know. I never looked at ampersand. So forgive me. I'll one other confession. So I got a D penmanship once. Maybe these two go together. So something, it was something like that. So we can call it the Osgood typeface or something. Okay, so here's this. And what is that telling us to do? It's telling it to run in the background, and that allows me to go do other things while this is still running, still doing its job. It may be churning through hundreds of megabytes of this stuff at a time and sorting and all that sort of stuff. And meanwhile, I'm typing other things into this whole thing. Now, how if at some point I want to turn that into a foreground process? What can suppose I know its ID, or suppose I know its job number. I can do FG, like %1, that's its job number. How do I know its job number? What's one way I can do that? Look for that. I can do jobs. And that will list for me the different jobs. Now, what's a job? Okay, it is process. All jobs are processes, but it's a certain type of process. What type of process? Okay, so a job is a running or it's a suspended process. So that much is true. What sort of running process? Okay. But the key point here is it's a background running process. A foreground thing does not count as a job, actually. A foreground process, one that's guiding your input interactively, is not counted as a job. A job is specifically, this is just how the terminology has evolved, and we're trying to defend it. But a job is used to talk about a suspended process or a background running process. What is a suspend process? How can I suspend a process? Let's suppose I'm doing this, and this this is taking much longer than I want, and it's chewing up my disk space and it's chewing up my CPU. How can I stop this? Suppose it's in the foreground. How can I stop it? Control Z. I could sort of do a Control Z, and it will then be a suspended process, okay, which is also a job. Yes, a question in the back? Done this offhand. Okay. So I can move things. Now, suppose I wanted it. Suppose I have a suspended process and I want to make it a foreground process again. Maybe I'm going to go to sleep, and so I want it to run, you know, overnight while I'm not there. How do I turn it into a foreground process? FG. I can turn it. I can get new jobs, and I can get it, and I can do FG. How if I want to turn a process that's suspended to a background process? BG. And similarly, I can turn it to a background process, and that will allow it to run in the background. It won't be expecting my input or something like that. Does that make sense? Yes. Question. Okay. It's a good question. So, from memory, so this percent sign is a specific syntax to mean a job number, okay? I believe there's, I'm trying to remember if it's a default thing. At one point I thought it was, but recent experience leads me to think it's not. That I think there's an option to FG where you can give it a certain option and then specify the PID for it. But that may not be universally supported. Maybe it's only in Sun OS. I thought in Sun OS I used to be able to do, you know, foreground 1001, and it didn't have the percent sign, and I could just but I may be misremembering or may not, because I'm pretty sure on Linux you cannot do that. But it may be that there's a command option to this that allows you to take PIDs. But I'd have to go look it up. As to that, I thought in Sun OS it was readily possible, but I'd have to go check to be sure. Okay. The normal option is, and the vast majority of time I've always done it with percent sign in jobs. Because jobs lists the jobs that are eligible for becoming foreground processes that aren't already foreground processes. So at the least it prevents misunderstandings or errors. It's a good question. Other question? Yes. Oh, yeah, sure. Let me see if I got a slide actually with that here. Right. So here, do I have kill? Yes. Yes. So this is exactly an example with a kill command. Okay. So here, kill takes various arguments, and specifically what kill does is it sends what's called a signal to the process. Okay, it sends sort of a message of sort, a high priority message to the process. Special delivery using terminology from another context. And so we'll say, for example, kill, and then you can specify, in this case it's sending a so-called sig term, but it can send a sig kill, which is a different sort of message, and it's more serious, saying you should die. Another one you can do is, the most serious is kill -9, and you can do kill -9% 1. Where does this percent come from? It comes from jobs. You look at the jobs. Okay, so that's an example of a kill. Yeah. Yeah. Has a number. Yes, precisely. So thank you very much for that question. So if I, really what I should have for this segment would be, I should really call up, oh, there it is, call up, go over to Tux World or something and go in here and I can go look, for example, I can go into Emacs and And you know, I can suspend Emacs. I press Control Z, and then I can say jobs, and it will tell me jobs 1 suspended Emacs. Now I could go into it again, for example, or I could say, you know, Emacs. I could have a different Emacs, or I could say cat, you know, something like that. Now I've got sorry, I just did FG, and so it did the last. It foregrounded the cat. So now there's 2 processes here. So if I wanted to make the Emacs the first job to bring it to the foreground, I could say FG%1, and it will bring this first one up here, Emacs there. Okay, that's my text editor. On the other hand, now I've just X'd out of that, and I could say I want to FG number 2, my cat, and then I could type, you know, things into cat. Does that make sense? Yeah. So good question. That's how it works. Okay. Great questions. Any other questions on this right now? Yes. Excuse me. I got some of your question. So suppose there's something that you want to end, but I think there was a salient point about it that I missed. So suppose that you have something in the foreground.
Yeah, you don't want it to like sentence out.
Yes. Yes, there is. Sure. So sure, you bet. So for certain things, so if I have cat, for example, here, and I do Control C, that kills it. It actually sends it I think it's a sig int or something, a certain signal that says, you got a signal that says, you know, back off or something, or you know, die, and it dies. Maybe it's a sig kill, I can't remember, but Control C actually sends it a signal. Now, some things don't like Control C. Some things will just blithely ignore Control C. For example, if I go into Emacs, I can press Control C, and it will say Control C is undefined, and it will not pay attention to that. So it's, you know, different. You when you write this my program, when you create a program, as we're doing this time, you know, C program or C++ program, you can decide what signals you'll handle and how you'll handle them, how graceful you'll be about saying, okay, you want to kill me? Fine, I'm out of here, and you know, backing off. So cat, for example, will leave. Emacs is more truculent as it is warm. Okay. Thank you. There's a high priority interrupt. My computer may encounter a sig kill unless I plug it in. Thank you. Thank you very much. Okay. So, much appreciated. Okay, so any other questions about this? Pipes. Okay, joining up pipes. We're going to be talking actually some about command substitutions and conditional commands later. I alluded to one of them. If you have, for example, foo, ampersand, bar, for example, you can make it conditional one, conditional another. Also, you can have one. It turns out that it's really nifty. You can have, so there's forward, where were we? So I had a regular expression up there at one point, but we put it in single quotes. Turns out you can have backward quotes, put commands in here, and it'll actually run the command and put the output from that command as an argument for another command. We haven't covered that yet, but pipes we did cover, and we talked about pipes. You know, it's providing here output from one is the input to the other. Okay, so the pair of streams here, one for writing, so the foo writes to the standard out, and one for reading, the var reads from the standard input. Okay, and as I said, you can connect any two as long as one sends one to stand out, the other reads from standard. And normally this is so readily done because text is used as kind of the means of communication. It's sort of common lingua franca. It's a common communication mechanism within Linux. Okay? within Unix more broadly. So we have this sort of communication. Later, we, as I said, will see how the options here can be specified by a first command. We'll see how that can be done separately. So we, for example, saw this. What does this cut do? Okay, and what specifically is this doing? It's taking the first three fields, you know, and extracting those and then passing it to sort, right? Okay, good. So pipelines, these things are different, folks. This is different from this. Here, how is this different from this one? Sorry? Okay. This erases the record here, but how is this different from this? Because they're parallel. They're running at the same time. Yeah. This one, they're running at different times. This is more like what it is in DOS, bearing in mind that, or Windows, bearing in mind that TMP is just any name that's not already a file. You know, it's smart enough to not create a file that already exists, but the point is this runs before, strictly before this one. Those semantics are just not identical. Imagine that you have something, this is putting stuff out that's coming in on the network and this is processing it. You could run this for days and days and days and it's doing lots of useful work because it's just reporting things coming in via the network and processing them as it goes. Whereas in Windows, you know, this completes before that. There are, of course, ways to get this in Windows. It's just from the shell, it isn't so easy. T. I spoke about T, I think, a little bit very briefly in the class, but I want to emphasize this. What's this T thing? What's going on here? Okay, so command 1 is running. T takes as its standard input the standard output from command 1 here. It puts that into file, but it also passes that on. It passes that on as its standard output as well to command 2. So, ladies and gentlemen, in case you're wondering about the name, it's like a T. It's connecting up command 1 and command 2, but also putting it to a file. So that's why it's called a T, right? Does that make sense to people? Okay. So here it's placing all the output in the file, putting it on. Ladies and gentlemen, this is really, really useful if you're trying to figure out what's going wrong or what's going on in the midpoint. Imagine you have a long chain of these things, one going to the next, going to the next. You can put these in between them. It'll still work properly, but you can get a peek at what's being passed along all the stages. Then maybe you want to take them out later on after it's working. Okay? So this is a very useful sort of mechanism. We talked about create sort of consecutive commands here. Escape characters. You can use backslash, and you can use the most sure option is often to put a single quote around it to prevent it, but you can use the backslash, for example, here, or suppose you wanted to have a name there, you don't want it to be interpreted as pipe, you can put a backslash before it. Quote character can be used here, but it will still interpret it. It still allows it to be interpreted. For example, as I noted earlier, it recognizes this as a single thing, that it's this name, but it does substitute in when you use double quote. If you want to use single quote, it'll prevent that substitution. And again, I want to emphasize it's something very different from a back quote. A back quote will be used later to allow one command's arguments to be given by another command. Okay? But we're not there yet. Okay, so that was comments on sort of Unix commands and that sort of stuff. Any questions on that before we go on to regular expression? Which is another thing we should be really comfortable with. Yeah. Yeah.
Using stuff that we using command 1, command 2, and redirection another 5 is the same thing.
Okay, so it's great. I welcome that. So if you said, suppose that you instead had here.
We don't use
instead had command 1, and then pipe command 2, and then into this file called file. What, ladies and gentlemen, is that going to be the same or different from that? How is it different?
Because the content might change the
Yeah.
input.
So, exactly. So this is dealing with whatever is outputted by command 1. Maybe command 1 is cat, maybe command 2 is sort. In which case, this is going to be putting the sorted version of this into file, whereas this one, if this were cat or something, and this were sort, this would be putting the unsorted version into file. Does that make sense? So this, the distinguishing thing is here, it's putting the output of command 1 into file. If we put this at the end, it's certainly meaningful, but it's doing something very different. It's putting the output from command 2 into file. Okay? So that's quite different. And this allows us to save away the output from command 1, even though it's in a pipeline. Does that make sense?
So how we, in the case that we have over there, the output of the command 1 after the 5 going to the 5, okay? So how we cannot have the output of command 1 here going after 5 to command 2?
Because the syntax here is not such that you could tell it, put command 1 out. This is telling it, the way this is parsed, okay, so maybe
What is the output of the command 1 here?
the output of command 1 is passed to command 2 as its standard input.
Okay.
Yeah, but it's not put anywhere. It's just passed here and it's never written anywhere with this one. Now you might ask, could you do something like this? Could you do something like that? But that's altogether, the standard input has already been used up by here. You're not going to be able to pass this on. So here, command 1's output is used by command 2, but it's never stored away with this one. Here, it's actually stored away in file as well as being used by command 2. Does that make sense?
Yes.
Okay. So, clarify. Okay. Any other questions? Yeah.
You can do all sort of redirections as well, right? Like even a parent you can overwrite a file.
Yeah. That's, I mean, with T.
Yeah.
Yeah, that's right.
Just do like two random and
So in other words, you could have this, for example, penned into the file rather than just writing it from scratch, that sort of thing? Yeah. My recollection is that T does support several options for that sort of thing. And so it's not purely overwriting the file, you can accumulate things there, for example. And this by nature is, of course, accumulating all, as long as command 1 is running, this is still accumulating all through that process, right? Okay, so other questions? Okay. So let's talk about regular expression. So I should probably nuggetize this. Okay, so